Imagine a single spreadsheet formula, run correctly, saving a company $40 million in wasted marketing spend. No new product, no new campaign. Just someone looking at the same data everyone else had access to and seeing what nobody else saw. Companies pay this person up to $140,000 a year to do exactly that. But wait until the end, and I will describe exactly how to get qualified and land a job in this field. So who is this person, and why does staring at numbers pay this well? Because every company on Earth is now drowning in data. Every click, every purchase, every support ticket, every sensor reading gets logged somewhere. Most of that data just sits there, unused, telling a story nobody's reading. Somebody has to actually read it, understand what it's saying, and turn it into a decision the business can act on. That somebody is a data scientist. Let's strip away the buzzword and look at what this job actually is. A data scientist isn't just someone who's good at math. You're part detective, part translator, part builder. Your job is to take raw, messy, disorganized information and turn it into something a business can actually use to make money, save money, or avoid a costly mistake. So, what does your actual day look like? You start by asking a question, not a technical question, a business question. Why are customers canceling their subscriptions in month 3? Which product features actually drive repeat purchases? Is this new marketing campaign paying for itself or quietly losing money? These are the questions that pay 6 figures, not the code itself. Once you have the question, you go hunting for the data. This is where the job gets messy, literally. Real-world data is rarely clean. It's scattered across different systems, full of missing values, duplicate entries, and formatting inconsistencies that would confuse a computer instantly. A huge part of your day is spent in a process called data cleaning, which simply means fixing all of that mess so the information can actually be trusted. You do this using tools like Python and SQL. Python is a programming language that lets you manipulate, analyze, and model data at a scale no spreadsheet could ever handle. SQL is the language you use to pull exactly the data you need out of a company's massive databases, the same way you'd search a filing cabinet, except the cabinet holds billions of records. Here's a question worth sitting with. If the data is just sitting there, why does it take a highly paid specialist to make sense of it? Because raw numbers don't explain themselves, and worse, they can actively lie to you if you don't know what you're looking for. A spike in sales might look like great news until you realize it was caused by a pricing error that's about to cost the company money. A pattern that looks meaningful might just be random noise. You are the person trained to tell the difference between a real signal and a coincidence, and that skill alone prevents companies from making expensive decisions based on nothing. Once you understand what the data is actually saying, you build models. A model, in plain English, is simply a mathematical way of predicting what's likely to happen next based on patterns from the past. Will this customer cancel their subscription? Is this transaction fraudulent? How much inventory should a warehouse stock next month? You build these using machine learning, a method where the computer learns patterns from historical data instead of being explicitly programmed with fixed rules for every situation. You also spend real time visualizing your findings using tools like Tableau or Power BI, turning walls of numbers into charts and dashboards. A non-technical executive can actually understand in 30 seconds. This part of the job matters more than people expect. The most brilliant analysis in the world is worthless if you can't explain it clearly enough for someone else to act on it. Beyond the analysis itself, you're constantly thinking about whether your data can actually be trusted in the first place. This is called data validation, and it's one of the most overlooked parts of the job. If a tracking system silently breaks for 2 days and nobody notices, every conclusion built on that data during that window is wrong, and wrong conclusions dressed up in a confident chart are far more dangerous than an honest, "we don't know yet." Part of your job is building checks that catch these silent failures before they turn into bad business decisions. You also live inside experimentation, often called A/B testing. This means running a controlled comparison, showing one version of something to one group of users and a different version to another, then measuring which one actually performs better instead of guessing. A product team might have a strong opinion about which button color increases signups. Your job is to test that opinion against real behavior and sometimes deliver the uncomfortable news that the strong opinion was wrong. Let's talk numbers, because this is where it gets serious. Industry salary data from 2026 shows data scientists earning a typical range between around $120,000 and $180,000 a year in the United States, with mid-level specialists at major tech companies commonly reaching total compensation above $160,000 once bonuses and stock are included. Senior and principal-level data scientists at companies like Google or Meta can clear well past $200,000. Why does the money get that high? Because good data science directly protects or grows revenue, and companies can measure that impact with a dollar sign attached. If your analysis stops a failing marketing campaign before it burns through another $1 million, that's not a nice to have. That's money in the bank, and companies pay accordingly for people who can consistently deliver that kind of clarity. Let's talk about who actually hires for this role. It's not limited to tech giants. Retail companies hire data scientists to predict exactly how much inventory to stock before a holiday season. Banks hire them to detect fraudulent transactions in real time, often within milliseconds. Healthcare companies hire them to predict patient risk and improve treatment outcomes. Streaming platforms hire them to figure out exactly which show to recommend to keep you watching. If a business generates data, and every business does now, this role has a place inside it. You rarely work in isolation either. Marketing teams come to you asking whether a campaign is actually working. Product teams come to you asking which features to build next. Executives come to you asking where the business is bleeding money nobody's noticed yet. You're constantly translating between raw numbers and real business decisions, which means you need to understand both the technical side and the human side of a company equally well. Think about what that means for how replaceable you are. Someone who only knows how to code competes with a massive global pool of people who can also write code. Someone who only understands statistics competes with every statistics graduate entering the workforce this year. You're not just one of those things. You're the rare combination of both, wrapped in the ability to explain your conclusions clearly enough that a non-technical decision maker actually trusts and acts on them. That combination is genuinely difficult to replace. This also shows up clearly in how responsibility grows over time. A junior data scientist might be handed a single, well-defined question to answer. A senior data scientist is often the one deciding which questions are even worth asking in the first place, shaping the company's entire data strategy rather than just executing someone else's request. This demand for a rare combination of skills is exactly why the shortage exists. Plenty of people can code. Plenty of people understand statistics. Very few people can do both, while also communicating clearly enough for a non-technical executive to trust their conclusions and act on them. That specific combination, not any single skill alone, is where the salary comes from. Let's be honest about the harder side of this job too. A lot of your time isn't spent building exciting predictive models. It's spent cleaning messy data, waiting on access to systems, or explaining the same finding 3 different ways to 3 different audiences. This isn't a job built purely on intellectual excitement. It requires real patience with imperfect, frustrating information. But that patience is exactly why companies pay so well for people who can push through it and still deliver a clear answer. So, how does someone actually break into this field? Start with the 2 foundational languages of the job, Python and SQL. You don't need a PhD to begin. You need working, practical fluency, which you build through consistent practice, not raw genius. Free resources and structured courses can get you functional in both within a few months of focused effort. Next, learn the fundamentals of statistics. Not abstract academic theory, but practical statistics. How to tell if a result is meaningful or just noise. How to design a fair comparison between 2 options. How to avoid fooling yourself with your own data. This is the skill that separates someone who can run code from someone who can actually be trusted with a business decision. From there, Build a portfolio project using real, messy, publicly available data. Pick a genuine question, clean the data yourself, build a simple model, and clearly explain what you found and why it matters. This single project, documented well, proves you can do the actual job, not just describe it in an interview. Most people entering this field don't start with the data scientist title. They often start as a data analyst, a business analyst, or in a technical support role that involves working with data daily, and pivot into data science within 1 to 2 years, once they've built the practical skills and a project to prove it. If you're already working with spreadsheets, dashboards, or reporting in any capacity, you're likely closer to this transition than you think. While you're building toward that pivot, look for opportunities inside your current role first. Volunteer for any task involving reporting, data cleanup, or basic analysis, even if it's not officially part of your job description. Ask questions about how decisions get made in your company, and pay attention to which numbers actually drive those decisions. Every bit of exposure to real business data, even informally, makes your eventual interview answers sharper and far more credible than anything learned purely from a textbook. Finally, learn to speak in business outcomes, not just technical methods. In interviews, you won't just be asked to explain a machine learning model. You'll be asked what decision it helped someone make and what it was worth to the business. Practice explaining your work in terms of money saved, risk avoided, or growth enabled, because that is the actual language this role gets paid to speak. One last thing that consistently separates hired candidates from overlooked ones. Document your portfolio project clearly with a simple write-up explaining your process and your conclusion, and make it easy to share with a link. A hiring manager scanning dozens of similar applications will remember the one candidate who can actually walk them through a real analysis they did themselves, instead of one more resume line claiming familiarity with a list of tools. So think back to that spreadsheet formula at the very start. $40 million saved by someone looking at the same data everyone else had and actually understanding what it meant. That wasn't luck, and it wasn't magic. It was someone who learned 2 programming languages, built real statistical judgment, and proved it with a genuine project instead of a resume line. That person didn't need a PhD to start, and neither do you. You might be closer to your dream job than you think. Not because of luck, and not because of some rare talent, but because the path is clearer than it looks, once you know it exists. So like this video, subscribe, and comment your current job or the career you're chasing. You might be one certification away from a door you didn't even know was open.